This is Protein Structure by David, Lexi, Tori, and Imani. What comes to mind when you think of protein? Most people would list you the things they believe to contain protein, such as eggs, steak, yogurt, or nuts. I'm sure you can see the problem with this. We haven't defined anything really, other than what the general public believes protein to be. If we go deeper into the steak and eggs, down into the atomic and molecular level, we find a molecule that contains a carboxylic acid on one end and an amine group on the opposite side. In the middle, bonded to a central carbon atom, is a side chain or R group. This is what we call the amino acid, the basic functional unit of the protein. The R groups from amino acid to amino acid are one of the 20 types which marks the 20 different amino acids, each with an interesting feature attributed to its R group. When two or more amino acids bond, they form a peptide bond. The unique arrangement of the amino acids as they form peptide bonds is what we call the primary structure. If we zoom out a bit more, we realize there are numerous primary structures. However, an interesting addition is that these primary structures begin to fold in on each other, forming sheets. This is the result of hydrogen bonding between individual amino acid molecules. There are two types of sheets, the alpha helices and the beta sheets. The alpha helices come from bonding between the carboxyl oxygen and an amine hydrogen in different amino acids, while the beta sheets have the oxygen on one strand and the hydrogen on a different strand bonding. The alpha sheets are stronger and more stable, while the beta sheets are less stable. Both are held together by hydrogen bonds. Such a structure can be regarded as a polypeptide. This is the secondary structure. This cartoon shows how proteins need specific bonds and energy from photons in order to properly fold and function. If we zoom out again much more, we realize that these peptide bonds can hold hundreds or even thousands of amino acids in the same strand. These interact by allowing the two-dimensional alpha and beta sheets to form three-dimensional complex curves. These curves can fold due to hydrophobic and hydrophilic interactions. This is the tertiary structure. If bonding in the secondary or tertiary structure of proteins is disrupted, it can lead to the denaturing of proteins. Proteins can become denatured through heat, acids or bases, and salts or solvents. Finally, if we zoom out completely and observe the entire protein as a whole, it can be seen that they can have more than one polypeptide chain. The different polypeptide chains in a protein are known as domains, and they interact with each other with the same interactions as those in the tertiary structure. This complex intertwining of different polypeptide chains is known as the quaternary structure. These four distinct structures could be specialized to perform different tasks, considering that the human genome is equipped to code for about 22,000 proteins, each with a unique function. Parkinson's disease is a progressive, degenerative neurological disorder that primarily affects movement. This hard-hitting disease leads to symptoms that range from general fatigue, dizziness, tremors, bent gait, and slurred speech. Many people have heard of this disease, but few understand the mechanisms that lead to it. It is a disease that affects the production of the protein and neurotransmitter dopamine. Nervous tissue produces less dopamine, leading to a state of hypersensitivity in the nerves of patients in order to fire up contact with the scarce dopamine reserves, thereby leading the nerve tissue to fire up randomly due to hypersensitivity. This distorts movement. It is more prevalent in people who are middle-aged and older. There are estimated to be over 1 million people living with Parkinson's disease in the U.S., with 60,000 new cases each year. There are treatments to enhance quality of life of sufferers, but currently there is no known medical cure.